All right, so we're going to be going over some examples of actually graphing secant and cosecant. So here we have our first one. We have 3 times cosecant 2x plus 4. Small thing here, right? Just make sure we know what's actually inside the cosecant function here. So this is inside, that plus 4 is on the end. Small thing, sometimes there's parentheses around this, sometimes there's not. All right, so we're graphing cosecant, which means that we're going to pretend that this is sine for the whole beginning here, right? Sine and cosecant are reciprocals of each other, so we use our sine graph to help us graph that. So we need to go through all the steps that are going to be necessary here for us to graph sine. So first thing here, we have an amplitude of 3, and we are not reflected. Right, there's no negative there, so this is kind of our standard sine curve, right? 1, 2, 3, max, min, right? We're going to be graphing something like this, minus the points, or minus the curve. We really just need these 5 points. So not reflected. Here we have a b value of 2. B equals 2, which means that our period is going to be 2 pi divided by 2, or just pi. Cool. Our c value, so in here we don't have anything that we're adding or subtracting, so our c value is 0. We're not shifting left or right, we're just going to be starting at 0 on the x-axis. And then d, we are moving this up. We are shifting it up 4 units, right? So we're going 4 up, that's where our midline is going to be. All right, let's go ahead and start with the scaling along the y-axis. So our midline is going to be at 4, and we're going to be going 3 above that and 3 below that. So we're going to be going up to 7 and down to 1. So 1, 2, 3, 4. That's our midline. 5, 6, 7, 7. I'm not going to scale anything else. I'm just going to leave it right there like that. And I'm going to sketch in those guiding lines that I like to do, where our maximum points go, where our midline points go, and our minimum points. Okay. Maximum, minimum, midline. All right. From here, what I want to do is think about my x-axis. And so we're really fortunate this time. One, our period is pretty standard. A period of pi is not too crazy. And also, we're not shifting it at all. So we get to start at 0. We have to go pi to the right because that's our cycle length, our period length. So we're going to be starting at 0. We're going to be ending at pi. Very easy when we start at 0, end at something pretty standard. From there, we do need to think about what we should count by. In general, our goal is to split up our cycle into 4 even increments. So that's pretty easy, right? Half, that's pi divided by 2. And then quarters. Well, that's 1/4 of pi over 4, and then 3/4 of pi. Again, this one's pretty easy because of our standard scaling of pi being relatively standard and starting at 0. If we ever have that phase shift going on, which we will in the future, and kind of a less standard one, we have to do some more things to think about the scaling. Remember, guidance that I always give is that if you take the period divided by 4, which in our case is pi over 4, that's a good one to think about. And we do need to compare that to the phase shift, compare that to the c value, and make sure that those are sort of compatible. But anytime you start at 0, that's great. You can just ignore this. You can just count by whatever your period divided by 4 is. And that's what we're doing. 1/4, 2/4, or half of pi, 3/4 of pi, and then pi. All right, I'll go ahead and stop talking about that. And let's now plot points. We're ready to plot the points, right? And we're graphing a cosecant graph, which means that we have to graph the 5 friend points for sine. So sine starts at the midline, in the middle it's at the midline, and at the end it's at the midline. At the 1/4 point, it's at its maximum, and at the 3/4 point here, it is at its minimum. We're not sketching in this curve. We are going to be drawing asymptotes, and we're going to be sketching in the cosecant graph. Now is the point where we can erase this here. We can ignore that we're talking about sine. We're actually graphing cosecant. So let's go ahead and plot that those asymptotes. So anywhere there is a midline point, so right here, there's a midline point. This is going to be a vertical asymptote. Here's another one. There's going to be another vertical asymptote right there. And the last one right there. So this one has 3 vertical asymptotes in the cycle. Cosecant always has those 3 at the beginning, at the middle, and the end, exactly like sine has those midline points there. From there, we just need to draw in the U-shapes that make our cosecant graph. And so they are going to happen at the minimums and maximums. So there's going to be one here and one here. I don't have a lot of space up above it, so I'm just going to sort of pretend that I have the space here. Make sure we approach the asymptote. There we go. So that's one of these. And then we'll just do another one down here. Not the smoothest curve, but we get the point. And that's one cycle of secant. We graphed it. We're all done. Not too hard, right? Once we graph the sine curve, it's not too difficult just to throw the cosecant graph on there. Awesome. So you do need to make sure you have your asymptotes plotted. If you don't plot your asymptotes, you know, that's not a full graph of cosecant. You need to make sure you have those asymptotes in there, and you want to make sure to draw in those U-shapes. You know, if you want to sketch in the curve for sine, you can do that, but there's no need. You just need the points. All right, I'm going to go ahead and freeze it right here for a second. You guys can you know, take a look at it, and all right, clear and move on. All right, so here's an example of a secant graph. So secant graph. This one's going to be a little more challenging. We do have a phase shift involved, and we have a fractional b value that's going to affect our period. We also have a reflection, a lot going on here. But since it's a secant, we're going to pretend that this is cosine. We're going to be plotting points to make a cosine graph, and then using that to actually make the secant graph. Let's go ahead and go through the different aspects of this function here. What are the different transformations that we have? So our a is -2, which means that it will be reflected. So when we go to plot the points, we're not going to do the standard points like this, right? We need to reflect this. So we need to reflect those. It'll actually be minimum, minimum, maximum. All right, we're going to be plotting a reflected cosine curve to help us out here. So just keeping that in mind, once we actually go to make the points, that it is going to be reflected. You don't have to write that down necessarily, but it is kind of helpful to keep in mind. Whenever we have a b value and a phase shift, we always need to make sure that b value is factored out like it is here. If it's not factored out, we got to factor it out, right? If it's written sort of like this, we need to factor that b out to reveal the true phase shift. It's all about actually representing the phase shift appropriately. So here, our b value is 1/3. Find the period from that. We have period equals, 2 pi over b. So 2 pi divided by 1/3, it's actually 6 pi. It's a pretty long period. That means we'll have to have a really wide graph here, and we'll have to make sure to scale that appropriately. Phase shift, we have a minus pi over 2, so that's going to be to the right pi over 2. We are going to start not at 0 like we did last time. We'll start over here at pi over 2, wherever that happens to be. I don't think that's going to be a great place for it, but that's where we'll start. We'll figure out where it needs to go in the future. And the last thing, a d value, a vertical shift. And in this function, there's actually no d value. It's 0 this time because we are not going up or down at all. We could think about there being a +0 here on the end, but you know, just not there. It's a 0. All right, so now we need to start scaling things and kind of making this graph work for us. So the two things keep in mind, we want to scale the y-axis and then the x-axis. So our y-axis, we have a midline at 0, so midline right here at 0. Our amplitude is 2, so we're going to be going 2 above that. 1, 2, +2, and then down 2 below that, and -2. So that's our maximum and our minimum for cosine. Obviously, the secant graph will sort of be on top of that and below that, so I wanted to give myself a little more space. You don't want to put the 2 all the way up here, because then I got to graph my cosecant, curve on top of that, and that kind of looks bad there. All right. Next, we want to talk about the y-axis. The x-axis. This is the one that's always a little bit tricky. I'm going to be doing some work here kind of in the middle of my graph. I'll erase it once we actually try to plot stuff, but there's two things to keep in mind. There's the period divided by 4. So period divided by 4 in our case is 6 pi over 4. That simplifies to be 3 pi over 2. Okay, so just our period divided by 4, that's kind of the incrementing we need to plot the 5 points, right? We have to split that period into 4 even increments. So, this is what this tells me to do. I have to compare that to my C value, which is pi over 2. I want to make sure that I use the smaller of these two increments. And if I can't sort of make them have a common denominator, I would want to make sure that I do. But in this case, they both have a denominator of 2. And my smaller increment here is pi over 2. So this is telling me to count by pi over 2 on my x-axis. Now that's a bit of a headache. That's a small increment relative to our period, right? Our period is 6 pi. That's like 12 times bigger than this. That's fine. So we're going to start at pi over 2. That's where we start. And we need to move 6 pi to the right of that. That's where we're going to end. So let's actually figure out where we're going to end. So pi over 2 plus our full period of 6 pi. 6 pi is the same thing as 12 pi over 2. Just get a common denominator here. Pi over 2 plus 12 pi over 2 is 13 pi over 2. Okay, so digesting this, I'm starting here at pi over 2, 1 pi over 2. And I'm ending at 13 pi over 2. So I need to have 13 increments on my x-axis to the right. I got to count 13 spaces. So this is pi over 2, 2 pi over 2, 3 pi over 2, and I want to get all the way up to 13. 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, 10 pi over 2, 11 pi over 2, 12 pi over 2, 13. Okay, got lucky there a little bit that I didn't run out of space, and then I kind of spread it out enough. So I'm ending there. I'm going to erase some of this work just because it's right in the middle of my graph. So let me erase this real quick. And I'm going to do the same thing down here. All right, so this is where we're ending. And where we're starting is at pi over 2. So this distance right here from here to here is a full cycle. It's 6 pi. We just sort of calculated that, right? We took our starting point, we added the period, that's where we end. And all of this incrementing is even. It's all pi over 2 units. We could, if we want to, mark every single spot and label it and everything, but that gets pretty busy. Let's not do that. Let's just kind of divide it up into 4 and then label those spots. So we need to take our full cycle, which starts here and goes to here, and divide this into 4 equal parts. Okay? We already did our period over 2, our period over 4, right? P over 4. That was 6 pi over 4, which we simplified to be 3 pi over 2. So this is telling me that quarter increments are going to be 3 pi over 2. So 1, 2, 3. This is going to be my 1/4 mark. 1, 2, 3. 3 pi over 2 would be another one here. 1, 2, 3. Here's my 3/4 mark. 1, 2, 3. My end. So I could sort of use this to figure out how many pi over 2 increments I had. I could count these spaces and I can say, all right, this is 12 increments all the way to the end. So halfway here is going to be 6. Half of that is 3, so 3 and 3. And then half of that is 3 here, so 3 and 3 and 3. And we just need to divide it up into these 4 even increments here. Now, my preference is to have this labeled, is to go ahead and label these places if we can. I mean, we know the scaling and everything, so it shouldn't be too hard. This is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which simplifies to be 2 pi. 5 pi over 2, 6 pi over 2, 7 pi over 2, does not reduce. 8 pi over 2, 9 pi over 2, 10 pi over 2, which is 5 10 over 2 is 5, so 5 pi. 11 pi over 2, 12 pi over 2, 13 pi over 2. So pi over 2 increments. Reduce them if you can, but you know, these are the only ones that we really need to be labeled, where we're starting, where we're ending, quarter, half, 3/4. Those are the only ones that really need to be labeled. You know, if you want to label everything, it gets pretty messy on there. All right, so that was a lot of asides there. This scaling thing is one of the more tricky things of graphing any of these trig functions. So now we're at the point where we can actually graph this. Yeah, I didn't draw in my guiding lines before, but I'm not gonna fit those in. I'll just you know, go without here. So we're graphing a reflected cosine curve, at least the points of a reflected cosine curve. So we start at our minimum value down here at -2. We're also going to end at our minimum value at -2. I didn't quite line those up well, so let me fix that. That's why these guiding lines are useful, because I can actually see where the things are. In the middle, we're going to be at our maximum this time. So it's right there at 2. And then here are our equilibrium points, or our midline points. I should use that word. All right. We are graphing not a cosine graph, actually. We are actually graphing a secant graph. So that's where we need to step in and do this part. We're going to put our vertical asymptotes at the midline location. So here and here. And kind of missed that one, but I can just move it. So there are our vertical asymptotes. And now it's just a matter of sketching in those U's. So this is a secant graph. So there's going to be one kind of full U here in the middle. And then we'll have these two sort of half U's on the side. So half U over here and half U over here. Again, this would continue over, but that's outside of our one cycle, right? This is where our cycle starts. This is where our cycle ends. So, you know, the graph does continue over here, but we just don't plot that as part of our singular cycle. We just graph the ones that we did, and we're happy with those. All right, so that should be our answer. One cycle of this graph. Some of the things to keep in mind as far as like what was going on here, the phase shift and the period change, those are kind of really tricky aspects of it, but it's no different than what we've been doing with our basic sine and cosine. I mean, that's what we're doing. We're graphing sine and cosine still. We're just kind of taking a step beyond that to turn it into a secant graph or turn it into a cosecant graph. So that's scaling. That's the really difficult part here. All right, I'm going to go ahead and stop the video here. I think I'm going to do a part 3. So see you guys then.